Okay, good morning. Again, my name is Randy Hafer. I'm with High Plains Architects here in Billings. I'm going to change scales here pretty dramatically from what we were just talking about and get down to a very personal level, an individual level, if you will. I'm going to talk about what we call urban frontier house because it is an urban frontier. Right here in Billings, the house that my wife and I are building. And we're trying to do, frankly, a lot of things that these guys are talking about, but on a very small site and in a kind of very direct way. And Michael was talking a little bit about some of the closed loops. We're all about closed loops. Basically, you think when we get done with this house, if it works the way it would work, with the notable exception of the lack of oxygen, we can take it up to the moon and be perfectly fine all on our own. So that's kind of what we're trying to do. The house, it's called Urban Frontier House because it's important that it's in the city. But let me just give you a little context for this. This little diagram kind of explains the evolution of housing, if you will. For many millennia, houses were pretty simple, made out of locally sourced materials, local sources of energy that were probably predominantly wood for fires. Pretty simple structures to build. They were inexpensive. Everybody could do it, but they're also really inefficient. And then what's happened over the course of the last 150 years as different technologies became available, we took the same housing model and started adding things to it. And until to the point now where we've got the typical house is actually quite complicated. Lots of different systems in the house. They mostly don't talk to each other, have anything to do with each other. And consequently, they're expensive and relatively inefficient. So what we're going to try to do is rethink the model and come up with a smart solution that's both efficient and inexpensive. And the inexpensive part we're going to have some discussion about later because that hasn't completely happened yet, but we're working on that. Whoops. So when we started this project, which actually for me goes way back to college, which now is just after the earth cooled, so it was a long time ago, but I've been interested in this idea for a really long time, and we are at a place now where it's actually possible to do this. So we really are looking to have a completely off-the-grid urban house. That means a house in a neighborhood on a small lot. So when we started this project, we established these 8 goals with the idea that if this is going to have any sort of useful impact, if it doesn't meet these goals, it becomes a one-off thing that is not of particular interest to me. So the urban site's one. There are way too many people on the planet for everybody to have their little 10-acre ranchette. So most of us live in cities around the world, and we need to figure out how to do that in a much more sustainable way. The low budget, what that really just means is a budget that's similar to what standard contemporary housing costs. We're not, at this point, certainly able to do it for less. And although we're doing the first, we're still in the range. We're not kind of at the upper end of the affordability range, but we haven't blown past it. We don't want to have ultimately any off-site utilities. So no sewer, no water, no gas, no electricity. Everything is taken care of on site. The house needs to be comfortable by today's standards. If we have a temperature that swings in the house from 50 to 90, that's not going to be acceptable. So we need to design it in a way that doesn't happen. Low maintenance. If it's something that requires a team of maintenance engineers on your household staff, that isn't going to work. So it's got to be something that people can take care of. It needs to be easy to operate. I can guarantee you I am not a rocket scientist. So I know a lot about a lot of things, or I should say know a little about a lot of things. And so if I can figure it out, really pretty much anybody should be able to figure it out. So that's a really important point. And then we want this to be something that's replicable and scalable. We're starting with a house, which actually turns out to be a very complex organism. There's just because it's a 24/7, 365 operation with a range of life activities that happens within it. And when you try to think about all of those things and how they interact, it is complicated. But we want to take that and make this something that's scalable. So this little diagram of what we're doing, and I'm going to focus particularly on the energy, but we've really designed this thing, and what's been interesting about it is that the further we've gotten into it, the more we've realized how far off course we are in terms of thinking about how we build houses. I mean, a traditional house today, you've got a plumber that comes in and does plumbing. You have an electrician that comes in and does electrician. The framing does framer. They really don't have anything to do with each other except complain when the plumber put his pipe or the electrician or the mechanical guy wanted to put his duct. Otherwise, there's really no connection. Well, we've really rethought that whole process. The other thing is to really understand climate. Every place, of course, has a different climate, so there will be different solutions in different locations. But we're in Montana. We're specifically in Billings, Montana. And beyond that, we're even on a specific lot in Montana. We do have, I like to claim, and I haven't so far had anybody dispute this, that we actually have, from a temperature standpoint, the most rigorous climate on the planet, in that we've got a temperature range from -70 at Rogers Pass recorded to 117 in Miles City, 187 degrees in about 250, 300 miles. I haven't found any other place on the planet that has that temperature range in that small an area. So this is a tough place. It's not easy. We're not in Hawaii where the temperature ranges from 83 to 85. You know, we've got very different conditions to deal with. On the other hand, we don't have to deal with humidity. So, but that also means that we don't have a lot of rain here. So we have these particular conditions, which leads to the building envelope really needing to focus primarily on insulation and ventilation. So you'll see those walls are very thick. We've got a really incredibly well insulated house, but we are doing everything on site. All the water's collected, treated, disposed of on site. The energy is generated on site through a combination of photovoltaic panels and a wind turbine. And then it's stored in batteries and used on site. So the specific thing I want to talk about on the energy front, because what we like to say, and I hope this is true, at least it's what I say, so for right now you have to accept it, that there's really not a lot in here that we're doing that's new. We haven't invented a bunch of things. What we've done is figure out a different way to put all these pieces, parts together to make them work together. But the one part that is really very innovative is the energy system within the house. And it turns out that we're certainly in front of the codes, and we're really kind of in front of a whole bunch of things, so we're not quite there yet. But the ultimate goal is to have a DC microgrid in the house. Because, as you know, all the energy that's generated off the panels or off from the wind turbine is DC power. It's stored in batteries. Those are DC. If we can use it from that point as DC, then we start avoiding the conversion losses. And so we can right away improve the efficiency. We start to look at how many conversions happen in the course of sending power from coal strip to your house and then into your computer or TV. We can eliminate all these conversions back and forth, all the heat that's generated that has to be disposed of, and use it directly and improve the efficiency of the overall system by about 20%. And of course, it'll vary depending on a lot of factors, but it's significant, which then means that your systems can be smaller to start with. So we have a very small 2.4 kilowatt PV system and a 1 kilowatt wind. Now, there's been a lot of discussion about why are we doing both. The PV is way less expensive than the winds, particularly at this scale. But for me, because I actually want to be off-grid, and we will have to start grid-tied because this is the big experiment. But I want to be ultimately off-grid. And as we all know, we're in a northern latitude, so we don't have a lot of sunshine in the wintertime. Days are short, the sun angle's low. So to balance the production, we've added the wind. And of course, one of the big things that we've done through all of these systems is look at ways that we can reduce demand within the house. So I think an average Northwestern customer uses about 750 kilowatt hours a month. Our anticipated, and we're pretty confident that we can meet this load per month will be about 300 kilowatt hours. And through the combination of the PVs and the wind, we think we can balance out that production on an annual basis to just about equal that 300 kilowatts. And then we will eventually have a battery storage system that will allow us to get off the grid because, of course, on any given day or any given moment, we may not be generating anything. So We aren't going to be off the grid to begin with because the battery world is in such flux and so much is happening right now that it just didn't make sense. So we've got a very small, just a 48 volt, 4-car batteries really right now is all we have. But we have started creating the DC microgrid inside. So all of the power basically from the switch level up, which is lighting and ceiling fans, is all 12 volt DC. It's all LED. The fans are 12 volt fans. So the whole house has been wired with Cat 5 cable. So there's a much smaller amounts of copper being used to wire the house. And the system, it not only is it lower, well, it's not even inspected by the electrical inspector because of the low voltage, so it's much safer. And it also has the capability of being smart. And since I'm not smart, I'd have to have somebody else talk about that part, but there are all kinds of opportunities that happen within that. And also, again, the LEDs want to be DC. I mean, they are DC. So we avoid all those conversions again when we just use those things directly. And of course, all the electronics want to be DC. Those will have USB ports that we can plug things into. They're right in the house without having to have the little adapters. Our refrigerator is DC, and it's a pretty much a standard size refrigerator, but it's astoundingly more efficient. They're made in California, and I'm pretty convinced that this company was started in the 70s by a bunch of hippies that were living out in the wilderness somewhere, and doing everything off grid, but they just didn't have a good way to keep their beer cold. And so they were a bunch of smart guys though, and they started working on this thing. So the refrigerator's DC. The other major appliances aren't DC yet, and so those are some of the issues that we're dealing with, but we're set up to be able to convert in time. We've been working with some folks on the East Coast, electrical engineers who are actually involved with the group that's writing the code for residential DC electrical systems. So it doesn't even exist yet. So the whole thing has been really interesting, the kinds of the technologies that are emerging now and the opportunities. But we think ultimately there's going to be really a tremendous opportunity to have decentralized power. So whether it's on a single building basis or a neighborhood basis, where we can use the DC electricity directly, we can save a huge amount of money on the production and distribution of energy, and also be able to produce or utilize and have more energy available for a given sized production system. So those are some of the advantages and benefits, and ultimately have a pretty interesting setup here. So all of this is, just flip over here. I did just want to verify or confirm for everybody that we are on a very urban site. So that corner lot that you see up there was actually a parking lot, but it's a neighborhood. It's one of the oldest neighborhoods in town, and it was purchased by the state of Montana in the 60s and used as a parking lot for an office building, which is that white roof, just right directly below that, about a block away. And the state sold that a few years ago. We bought it, so we've used that as our location. So we're close to downtown, but we're in an older neighborhood, small lots, 50 by 140. We're trying to do all of this on that. So here's the big news. Just yesterday, we got the wind turbine installed. It took 3 hours, which was pretty remarkable. So we haven't had a big wind event yet, so it's sitting there. But it was actually good weather to do the install because we weren't battling any wind either. So that's where we are at the moment. We're hoping to be able to move in before the end of the year. This has been a pretty long process for a relatively small house. I mean, we're in the 13th month of construction. Lots of learning along the way, and this is what more or less what it's going to look like when we get finished. So we're pretty close and looking forward to a whole new big adventure. I mean, there's a lot of stories about a lot of other things besides just the energy side. The water side, I think, is really interesting, but the materials and sourcing has been really interesting as well. This house is incredibly insulated, and it's going to be astoundingly tight. So we've really reduced heat loss and heat gain through how we've developed the envelope. We are hoping to achieve, for any of you that know any of these programs, Living Building Challenge as a fully certified house. There really aren't any yet anywhere. That's the most rigorous green building standard in the world, and it really is the end game. You don't have options like LEED. You have imperatives, and you meet all of them, which include all of these things. You have to be off-grid, you have to supply your own power, water, blah, blah, blah. And it also has to be beautiful, and there's a social equity or social justice component to the whole thing. So it's a very, very rigorous program that we've been working towards. We're also looking to meet passive house standards, which is an energy-only standard, and LEED Platinum. So if we can pull all that off, we'll be the only building of its kind anywhere to achieve all of that. So we've set out some really ambitious goals, and it's been astoundingly difficult to get there, but persistence, that's kind of what it takes at the end of the day. Just keep plugging away. So I guess we can take questions.
Is that for questions?
Yes.
Could you talk about what is your square footage, and did you run into any issues with zoning a urban turbine?
An urban turbine. Okay, those are good questions. Let me just back up one or two. Where to go? That one. Okay, so first of all, as you may or may not know, the state of Montana requires that you connect to city services if you're in a municipality that has those services. So we had to get a variance from DEQ, or I think it was more like special dispensation from DEQ to do this. But the city of Billings was great and was helpful in getting that done, so that we were able, because that frankly was the biggest hurdle I thought we were going to have. And I'm pretty sure, just from reading that I do, that it would have been virtually impossible almost anywhere else in the country to do this, to have the opportunity to do this thing. The urban turbine, again, this is the first one, certainly in Billings. I'm not sure if there are any other urban turbines in the state of Montana that were permitted without any variances. When we did set up a meeting to go down and talk to the planning, and I've worked with these folks for a long time, and the woman that we were meeting with, when we first got there, was really tense. And I could tell right away she was pretty sure she was going to have to tell me no, and wasn't really looking forward to that, and figured I was going to be arguing with her. But when we sat down and showed her what we were doing, this turbine is only 23 feet 8 inches high. Zoning limit is 34 feet. Where it's placed on the corner, there's a limit of 12-inch diameter tree trunk or sign pole or whatever, and this is 10 3/4 inches. The blades don't extend over the property line. They're more than 8 feet above the ground, and we got all done. And actually, this is Taisei Techno out of Japan is the company that we've been working with. Billings is their beachhead in the U.S. And this is their first privately owned system. It's a market they're very interested in getting into, so we've been working with these guys for 3 years. But they were along at that meeting with the city, and for some reason, he had a video on his computer that we could show her what one looked like in Japan, and it was painted pink. And she loved it, because the first drawings that she saw, she just assumed they were all metallic, and she thought they looked too industrial, and that was going to be a problem. But when she saw the pink one, she said, "Oh, you can paint it?" She said, "Yes." So anyway, so we literally did not have to get any variances, nothing. The city did decide to permit it separately from the house, which was kind of a decision they made on their own, which was fine. So we kind of had a separate set of questions we had to go through for that. But so yes.
So are you not connected to city water or sewer?
We are not connected to city water or sewer at all. It goes right by us. So we have it's all done internally, and I'd be happy to tell you more about it. I think that's a very exciting part of what we're doing. Yes.
Given that this is kind of just a special variance, if this happens more frequently, is that going to make the city a little cranky if you're not connecting to their services? Because generally, like sewer and water, their ability to provide those services is driven by having additional customers. So what's that going to do to their
Well,
city's
these are all,
business?
yeah, these are all very interesting questions. And the city of Billings right now is looking at, I don't know, a $300 million expansion of the water system and some huge, tens of millions of dollars expansion or new waste treatment plant. So Public Works, frankly, is very interested in seeing these kinds of things and not adding load to the system.
Okay.
And when you start to think about this, I mean, we've built in our society certain kinds of systems that tend to, they're expensive. And as they age, because, they're all relatively new, but as they age, then the replacement costs, repair costs are also very expensive. If we can figure out other ways to do things, maybe we can eliminate some of those costs.
We have about 4 minutes for questions, so if you have questions for the other two as well, let's just open it up to anyone.
For your water capture system, how many gallons would you
We have-
estimate you're gonna get off your line?
We've done a number of water systems, and so what we've learned here is that storage is everything, because we'll have these major rain events, and if we can't capture all of it, then that's a problem. So we've been through things where we've tried to really tailor it to, looking at all kinds of averages, but we're never average. Average doesn't mean anything around here. So we actually have 9,000 gallons of rainwater storage and 1,100 gallons of gray water storage. So we have lots of water. It will take a while to fill up, but once that's full, and we're actually recycling some of the gray water too. The gray water is treated and then it's reused for dishwashing and laundry. So there's a certain amount of water that gets reused, but we also irrigate the whole place. The yard will be all vegetables and flowers and irrigated, no grass, but all of that water comes from what we can capture and use and reuse.
You're treating that rainwater to make it potable?
Yes, yes. We've learned a lot about that too. But actually, it's not that difficult to treat rainwater because, of course, it starts out life as distilled water. And it falls through the sky and it can pick up some things on the way. And of course, it can land on the roof and some pigeon may have been sitting there. But those are very dilute pollutants, and we don't have to deal with heavy metals and petrochemicals and that kind of stuff. As long as we're not dumping oil on the roof, we're not starting with very contaminated water to begin with. And that's one thing people forget. They say, you're dealing with rainwater. Well, we're dealing with Yellowstone River water, for crying out loud. I mean, it's got all kinds of fertilizers and stuff that get washed into it, and some dead cow upriver somewhere, and all that gets treated, and we don't have any of that stuff to deal with.
Jeff?
Could you talk about how you did your site mapping, your wind mapping to determine that the urban turbine was feasible in this location?
Yeah, we're a little bit out on a limb there. And frankly, the part of the deal is we're working with, as I mentioned, with Taisei, the company that's making this wind turbine. And we do have a corner site, and you can see we've located it right on the corner. We've got wind data from as close as 3 blocks away. They've got they've got a turbine out at City College. It's a 10 kW unit that was their first one that they've been monitoring for years. They've got another one on North 32nd that's their own unit that they've been monitoring. So we've done a lot of extrapolating to try to get to this location. We will have a weather station on the house, so we'll be able to know exactly what our conditions are. But we don't have specific wind data for this site. So we're going with what we've got that's close.
Over here?
How did you get your neighbors to buy off on a wind turbine right next to them?
Interestingly, that hasn't been a problem at all. The neighborhood is very excited about this house. This is an older neighborhood, smaller houses, lower income, and I think that my feeling is that the neighbors in general, because they've all been very friendly, they're very excited about the house. I think they're excited that this is happening in their neighborhood.